Mogu da počnem? Okay, what do I need here?
Is this okay?
Ah, great, yes, perfect. Yep. Zdravo svima, kaj da počnem? Today we are going to talk about contracts. And you can find like a lot of different talks, blogs, topics around contracts. I will not go into like theory, why do we need like defensive programming, I will not cover this. I will do like some mentions if you want to like research on your own terms. I will not go into like deep introduction to contracts or deep how to use them. I will cover like what's the most, I think, interesting right now with contracts is all the drama. Like, because maybe you have seen like on Reddit, on some talks from Bjarne Strauss too, from everyone, like a lot of dissatisfaction with the current state of the contracts. You probably know they're like right now in the working draft, which means if they're not removed, they will go into C++26, but there's like non-zero chance they could be removed because the last time contracts were in the working draft in C++20, they were pulled out. Like, it's not a very pretty process. Like, usually a lot of different stories about this around. And today we are going to get to the gist of it. Like, what's the problem with contracts? Like, why everyone is mad? Like, how can we find a compromise? And it will be kind of like a rant, and I will make a poll, and you will like this poll, for sure. So let's start like some basic idea of what the contracts are. You kind of can think of them in the terms of like macro assets, right? This example I took from Herb Satter's talk. It doesn't mean much. It's just to showcase like what can we do with contracts on an example, basically. Like, who doesn't know like what contracts are at all? Maybe doesn't. Yeah. Okay. So contracts. With macro, we needed like some header, and assert was a macro, right? Like plain and simple. In release mode, it was elided completely, nothing is evaluated. In debug mode, we check it out, and it will call like terminate if like with some message if it doesn't pass. Contracts, the idea is to introduce core language to support this statement. So instead of a macro, we have some language constructions which support different cases. Like for direct macro assert replacement, we have contract assert. It's pretty much the same, like not much different. But we have additional two constructions, which are called pre and post conditions. They're defined on the declaration of a function in this case. And features, we don't need a header. And there was a quiz last year, and some of the people got a little bit surprised that the only keyword in the contracts is contract assert. Like this table in the standard defines all the keywords. They're like global identifiers which are defined as keywords. But post and pre, they're like context dependent. They're identifiers with a special meaning. But it's like a little bit of a trivia, it doesn't matter much. Like that, we can just use post and pre as variable names in some contexts, for example. It's made to not break old code, of course. So why do we need all of this stuff? Why do we need contracts when we have like asserts, right? It's not a macro, it's visible to the compiler. Like we can actually do things around it. Potentially, with some examples which we have seen, we actually could improve static analysis with them. Also, it eliminates like bit rot. If, for example, you have some old asset macro in a code base which like never called in a different mode, like in debug, for example, always in release, you will never see like an issue with the sessions. It has configurable semantics. Right now, they're global. Like you have a code base which uses contracts, and you can choose how, like similar to release debug modes for assets, but we have additional semantics. Like we could not just of course, we could ignore in the release mode. We don't do anything about the evaluation, zero runtime overhead. We could enforce the semantics similar to the debug, but it will call some contract violation handler. like there is a customizable behavior. There's observe. Observe is a very peculiar semantic that is a hard requirement for some companies like Bloomberg and Apple. The idea is that sometimes we want to kind of evaluate this assertion, but we want to proceed further. We don't want to stop the program, because sometimes, like the most obvious example, we have an old program which is working in production right now, and we want to introduce contracts to this. Like, this program is not wrong. There is no like bugs at all, and any contract violation in case of such introduction will be likely a bug in our own like contract definition. Maybe we didn't know that it behaves in a certain way. And we don't want to immediately like terminate this program. We need to catch this error, log it like, okay, we need to look into it further, and proceed to catch as many errors as we can. It's customizable with a special function definition called handle contract violation. It's customizable similar to operator new. User can provide their own definition and link it to the binary, like from application. And it's obviously visible to a caller when in declaration. It's usable sometimes like you have your definitions in the source code. You don't know like what is the contract of this function is. You rely purely on comments. But we can move out this language contract semantics into the declaration. It's very useful for self-documentation. And it will be actually factual if we use different semantics, because what we see will be evaluated at some point. Postcondition can refer to return value. It's because usually when you return something from a function and it's a non-movable type, we can't really like check it like in an asset, because we need to return it. Like only copy elision like work like for PR values, we can return non-movable types. But with contracts, we can refer to this return value. So it's a nice thing to have. It prevents time travel. It's not quite intuitive like what it is, but we will get to it later. It prevents ODR violations. And it's kind of technically prevents us. Not a lot of people see like using this from the practical standpoint, but some people believe it's a crucial aspect, and we will also get to this later. And there are a lot of talks. I recommend like every single talk by Timur Dumlev. He's like an exceptional person who does like this, pushes this proposal with exceptional patience, precision, like everything is great about the process which he made. Also, if you want some like theory, there's a talk by Dave Abrahams and Sean Parent. They go into like some details, like how we change, how we think about semantics of like exception correctness, how contracts fit into this, and all of this stuff. And when you look for contracts, you sometimes can find like talks like this, like how we would program these contracts in C++20, which right now we know it didn't quite work well. It was very fun to watch it like when I was preparing for the talk, like to remember this lost age when everything was great. And this is a screenshot from one of the Timur's talks, which showcased like this long story how contracts came to be to this point in C++. Initially, like one of the first papers which started to talk about contracts as C++ talks about it is made by Bertrand Meyer, called Design by Contract, if I'm not mistaken. It was like 40 years ago. And one of the first proposals to C++ was based on this proposal. And this paper also influenced like a lot of known like languages like Eiffel, for example, which will be referred to a little bit later. But community there were like there are some mathematical like mistakes with this idea, with this theory. Right now we know we could do better, and actually a lot of the decisions which a lot of people don't like, for example, support for virtual functions, which is not there yet. It's not possible exactly because like the logic is not sound for them. And this proposal from 2004 was before John Lucas. Yeah. In 2040, Bloomberg, they came out with a proposal based on the internal implementation of this contract idea, but based on macros, and it didn't go quite well. And after this, up to C++20, we had this joint proposal, which was matched into the working draft, but also it was rejected with flames. After this, the committee decided to organize a study group. Okay, we need to like step back. We need to check, okay, what can we do differently? Why did it fail? Like, how can we compromise some common ground to push this feature forward? Because everyone agrees that we need this proposal in the committee, maybe. Here we will talk a little bit about C++20 fiasco. After the proposal was accepted into the working draft, which was due to release as C++20, a lot of people came and started to do a lot of changes because they realized that the feature is not quite fit for their case. And proponent in the end, like when one of the groups like EVG decided to, okay, what's going on? They started to talk with authors and proponents, and no one could figure out what actually the proposal did. No one had like a single unified idea. And a lot of developments were actually done like in the committee halls, like on the fly, effectively. And in that, everyone agreed that yeah, the proposal is just not ready yet. We can't agree like what are we doing. But there were also like technical limitations, like contract-based optimization caused issues, like this called time travel optimization. Like when we check in the contract some condition, for example, if a pointer is not null, compiler in C++20 could use this check to argue about like the other state in the program. And also go back, for example, with one of the semantics that's called observe. If we check like that null pointer is not null, and after that we'll try to use it, this pointer, compiler could technically go back and elide this check for the null pointer completely. Because like if we do observe, so we just move past this check and try to use this pointer, then it's impossible for the pointer to be null pointer because it's undefined behavior. It's also introduced a lot of undefined behavior, for example, when we try to retrofit preconditional existing binaries. Like in big companies, it's a lot of problem with ABI, and it's a big pain point. And there was a thing called axioms, which we know right now as attribute assume, where like compiler was allowed to optimize based on the like check in the contract. Right now, it's not possible. Compiler in the current working draft that is not allowed to optimize based on the contract violation checks. Yes. And there was a big issue with continuation mode, which is known as observe, which is a hard requirement, as I told you, for Bloomberg and Apple, to introduce contracts into big code bases. We can do without it. And you may have seen during these times, like this drama spilled in like social media. For example, you could find like these comments on Reddit, like it's like the very cheerful, like funny bunch, like everyone had very high stakes on this feature. Or for example, like this. And worse nothing, like it's not really like, yeah, of course. Yeah. And I must say, it was worse in the mailing list. Like, it's what you can just see on Reddit is like more presentable kind of communication you can see in the committee. Yeah, we could come back later, I guess. After all this drama, committee decided to organize a study group, like a group which decides to work on this contract feature like exclusively. They research 196 use cases. Like, so we can't really say that like they didn't do their homework, they missed something. They check like every single stakeholder on the contract, which in previous discussions in big companies, they identified like a lot of use cases for how contracts are supposed to be used. Like, it doesn't mean this proposal will support these use cases, but the proposal will consider the use cases. It's a very big proposal. It's like 119 pages. The ranges proposal, which is considered one of the biggest ones, it was 220, I believe. So like 2 times smaller, but still very big. And it, in addition to the main paper, it has an additional rational paper where they explain every single decision they made. Like from the get-go, they decided to document every single bit of information that goes into this proposal. They base the design on 6 fundamental design principles to avoid an issue when somewhere down the line someone comes in with some idea which they believe is better. We need some restriction on the design. We will discuss a little bit about them later. And yeah, because we have clear documented history of every single reason in the proposal, it's much easier to argue with opponents right now. Because if someone comes in with the same question like we had a year ago, 2 years ago, and nothing really changed, why do we need to repeat ourselves? We can refer to the same documentation, to the same poll, to the same discussion, everything. And because of that, contracts actually kept their direction very clear. And the MVP proposal, it's not one-off thing, Bloomberg is invested considerably into it, and they have a lot of papers pipelined after this one for additional extra features they have for multiple years plan into the future, how to expand on this feature. So it's very well sorted out. And of course, it's very worth mentioning, it's the most, no joke, well-researched and well-considered feature we ever standardized. Not a single one proposal which was included into C++ was as well researched and supported by discussions, poll, everything like this. So there's no reality where we can say that authors forgot something because they just themselves like it. No, everything is supported by some reason. Yeah, biggest issue. People new set of eyes comes in, because we are late in the process, people are looking, okay, C++ 26 is going to be out in sometime in a few months, in 6 months. And we need to quickly find some issue, we need to fix everything. Maybe something they don't know what they're doing. There's some critical flaw which we need to stop right now. So we need to pull this feature out. And it doesn't quite work like this. So I talked about some design principle, and the two which are very important, I believe to me, they have the so-called prime directive. The idea is that contracts should be invisible to the runtime of the program and to the compiler. We shouldn't be able to reason about if some semantic of contracts is enabled, we enable different behavior, because then contracts are pointless. What's the point if when we enable contracts, we silently choose to do different things, and when we disable contracts, then all hell let's loose. And they explicitly decided to define all new behavior. So the idea is that it's not necessarily specified to do something, but you get what you get. We don't say that it's undefined. There's some definition depending on the implement. It's not even implementation defined sometimes. What you do with contracts, you get that. For example, if you invoke undefined behavior with some expression using contracts, you get undefined behavior. Contracts don't help you with this. It's very important. Quickly, we will go over some contracts trivia, which may be interesting. Contract accession can be related 0 or n times, and with possibly different semantics. It's sometimes configurable from the compiler. You can set explicitly in Clang, I believe, how many times a contract will be related. It's to detect things like side effects. And it's very important to understand, contract is not necessarily going to be even in the same scope. One contract can be evaluated technically, and previous could be not, or maybe not sure. Post and precondition are not Svinaya contexts. If you use contracts in some templated function, and there's an issue in this condition, for example, you do some operation like a plus operator on a type which doesn't support it, it will not Svinaya error out. It will just a plain error. You can do template stuff over this. Semantics are not detectable at compile time at all. One of the things is that do this is contract accession. It's a statement. It's not an expression. Why? Because with expression we can check no except, and we don't want to check for this. Yes. And one of the ones, implementation may offer like some non-empty subset of the semantics. For example, you have like some critical safety code-based standard library. You don't want to observe semantics at all. You always want to check contracts. And implementation is free to do this. Like, it's not a problem. There's one fun bit that they actually could be called from the caller or caller side, and implementation are free to choose how they do it, and maybe sometimes mix it. And this is one of the reasons, like, we can't really define how many times a contract can be called. Like, implementation are free to call it like one time from the caller side and one time from the caller side. The other way around. Yeah. So the state of the MVP as a minimal valuable product, like some of the things which got into the working draft, like are missing. There are no user messages. Like you do like the old macro stuff with like logic, like short circuiting. There is no component-based semantics. Like all semantics are global. But we have a feature lineup for the future, which is called labels. But right now, like all semantics, like whatever libraries, dependencies you use, like you apply all contract semantics like to the whole translation unit. There is no support for virtual functions, which we told about. One of the cases, like why, for example, I'm not quite sure because I'm not an expert in this specific case, but what I was told, imagine you have a base class with some function which does math on like specific range of the numbers. And you say like, okay, precondition is this narrow contract, like this from 1 to -1, for example. And the output is the same. But for example, if you would use a deriv type, why is it a problem if it accepts a wider range, but it will only output the range of its base type if it's passed in its base type range? So a little bit complex, but it's very possible for deriv type to expand the range of inputs if it can guarantee that only for the expanded range, it will violate postcondition of its base class. For example, if on the base class we have -1 to 1 input range and output in -1 and 1, the deriv type can guarantee this, but it can also expand this range of available inputs. Another issue is no support for function pointers. It's just very hard issue, I guess. But also, for all of this stuff, the additional papers line up. But it's just not decided yet. There's some model to solve it, but people in the process of deciding, is it what we actually want?
Just a question, when you have a function pointer in the precondition or postcondition, you just not compile it.
Why?
Call to function.
No, sorry. It's no support for function pointers. It means that we can put precondition, if we have a pointer to a function, and when we call this function through this pointer, we can put this precondition on this function pointer.
So like we cannot evaluate function pointers, or we cannot call true function pointers.
We can't put contract specifiers on a function pointer, like.
So, but the contract specifiers are expressions, like, I don't know, function pointer, call to function pointer greater than 0, something like that. We cannot use that in the, because if it asserts we can.
No. We, like, maybe I misunderstand the question a bit. Like, when we call a function, we can use, like, for example, function parameter as function pointers. And we can operate on this function pointer inside the function. But if you want to store some function in the function pointer, you can put precondition on this call, which we do from this function pointer itself. But when we call into the function, if you pass pointer into this, you can, of course, do stuff with pointers as usual, like check for null pointer, like.
But like I said, the same with the virtual functions. Am I missing something here?
Maybe we'll talk after this, I guess.
It's just that if you call a function through a function pointer, you don't invalidate the contracts it has. Or you can't add.
You can put on them, yes. There's some specific issues about, like, for example, if you have this precondition inside function, right, and you store this function in the function pointer, it's not actually guaranteed to be called at all, because we have caller and caller semantics, and depends on the implementation. Yeah,
What you're saying, you cannot put contract on a function that will be called through a function pointer.
We can, but we can't rely on them being invoked.
And the same for virtual function. Everything that's not called directly.
On virtual function, we can't at all. We can't put even on the virtual right now. Yes. There is no post-condition captures. For example, we want to store like previous state of our function parameters to check that like our return value in some way related to this. And the very implementation defines like 31 times in the proposal, which is a very big, a big point people refer to, but we will get to it later as well. So do we need contracts in C++26 without this solved? Maybe like, who sees some value in this? Or maybe who sees that like without all of this, it's like there's no point? Okay, no one. Yeah, I promised you a bit of a rant, and I'm getting to that slowly. It's like the discussion spawned a lot of like papers, like contracts make C++ less safe, like full stop. Like it doesn't make any decent definition, like what are we talking about? Like what do you want from us? Contracts do not belong in the language. I'm not even sure if contracts are specified would pass regulatory requirements. Like, and I can assure you they didn't consult like any person related to regulatory requirements. They just, okay, I'm not sure. It's a fair thing to say. Yeah, one of the papers states that it's a powerful tool to new supply chain attacks, which it was an interesting one. And there are a lot of papers on the line of Microsoft doesn't want this feature at all. Like, they don't consider it's ready. They recommend against it. They continue to recommend against it. And there were a lot of comments that Microsoft is not going to implement them, even if they're like, if the C++26 is released with contracts. One of the issues, next we will cover some of the issues, all these papers we're talking about. A peculiar thing called constification, the so-called, it's the issue that the types which we use in contract predicates, it's not quite expression. Effectively, what is contract expression is officially called contract predicate. It's what you use inside the contract specifier. It will be deferred as const. Like, for example, in this case, this contract accession will pass because type is actually const inside this context. It affects overall resolution, which is kind of problematic, but we actually have the same behaviors with lambdas, like it happens. One of the issues, it's a shallow const. For example, you can like avoid this thing by, for example, using a pointer. Pointer will not be inside const. Like, it's just our best effort to maybe catch some errors. It encourages correct practices, like your code needs to be const correct if you want to use contracts. But you can use const cast, and it's actually completely legit and intentionally opened for you, like if your code base is not ready for modern C++ yet. Yeah, it helps to fight latent side effects, because usually when you call a function which is not const correct, it maybe does something which is not quite right. There were a few cases, maybe in Boost, I believe, which were found when it was tested. Is it fine? Like, who believes it's like maybe unnecessary? Maybe it's like, it's a crucial problem. Like, no, okay. Another issue, it doesn't catch UB, right? So we can just like add the reference and null pointer in contracts. It's still UB. Contracts don't do anything about it. Like the consequences are still the same. But contracts do not introduce new UB. Like it's like what you do is what you get. Maybe someone thinks that contracts should somehow like prevent UB in some way. Okay. And of course, one of the issues with this, you technically could make contract like this, which will not make actually much sense if you think that UB should exist, because this statement is allowed, this expression allowed to be elided. So it's effectively pre-true, like, doesn't make sense. Yeah. There's actually papers for implicit contract violation, which are trying to catch some of these things, but obviously cases like elision, it will not get to it. It doesn't do anything about no side effects, because it's a very hard problem to prove there's no side effects. You need a lot of machinery, like extra core language stuff in the language, or maybe not core language, but maybe at least attributes. Like, if we want to actually try to prove that we restrict set of operation which we do in in contracts to somehow prevent side effects, we couldn't even call vector.size. It's not possible, because the pointer could be null, and the compiler can't really argue about this. Inside this pointer could be null inside the function. So it's yeah. So because it's too restrictive if enforced, the paper does you get what you get, but it's not undefined and unspecified what you get. You get what you get, in the sense that when you do some side effects, you will get something, but depends, it's not undefined, it will be some value. It could be 0, it could be 2, it could be any n, doesn't matter. Another issue is throwing violation handlers. So we could customize behavior when contract is violated with this user-provided definition. And technically, we could make this contract violation handler both no except or no except true or no except false. The issue is it's not visible to the compiler if it's no except true or no except false. So compiler is kind of forced to always assume any contract expression will throw. It's a big problem, right? Because we know, for example, if we would use this function in a no except function, a contract expression in a no except function, compiler is forced to generate this code again for exception catching because it needs to terminate. It can't prove that everything is no except inside the function. Yes, so therefore potentially throwing. And compilers are in a very different situation, but there's a tool for that. Compilers actually can wrap these calls in a additional function, which is actually no except. So we will only generate this additional catching code inside this function, but in every other no except function, there's no additional code again. So it's solved, it's not a problem. Another problem, which is actually important, we can throw during contract evaluation, but by the current working draft, it's forced to pass this exception to contract violation handler. So it needs to translate this exception somehow. And it's needed so we could actually catch exceptions in contracts machine, in contracts language somehow. But it's possible to rethrow from the contract violation handler, so we would not actually terminate. We will escape this contract violation handler, even in forced semantics. And it's intentional. It's it's intentional loophole to the language. It's used for some, for example, if we want to do testing on contract statements and stuff like this. It's obviously the issue that we are not sure how we can detect. Yeah, because otherwise, if we would not do it, then we could throw an exception in a contract accession and catch it from outside to detect which actually contract mode we are doing. It will violate the prime directive. And the big issue is Microsoft is actually concerned about implementation cost, because the implementation of exceptions on x86 it's very problematic. It generates a lot of code, which also affects performance, on a happy path. So they're against it mostly for this. And we are not sure what to do with this. And of course, yes, we could use function, no except function. So compilers could technically omit everything. So maybe it's not that much of a problem for Microsoft, who knows. Yeah, one of the issues is observe semantic. It's when we have multiple contract accession in a function, and we check them, but we don't actually terminate or do anything. So in this case, we will check that the pointer is not null. It will log that, okay, it's not a null pointer, and then it will dereference a null pointer, like effectively invoking QB. And you need to do like this. It's very similar to macro, but not quite, because observe semantic is not present in macro. It's like picking additional gotcha of the contracts. But we also talked about time travel. So in this case, it's a problem. But compiler is not actually allowed to remove this check, because otherwise we would not be able to log this issue before undefined behavior like wreaks havoc in our code somehow. And yeah. Another issue is called mixed mode. Because we can customize semantics based on the translation unit, the issue is we can compile two different source files with different semantics. One is observe, another enforced. And we have inline functions, and these inline functions are working in a very interesting way in C++. And it could happen that it's not clear which of the semantics we will get when we compile, for example, our application, and we have some additional library which uses the same library with inline function, but it forces its own semantic in some way. Actually, our own code, which we explicitly specify to enforce, may observe. And it's a very big drama around this. But technically, it's a consequence of a C++ compilation model. We can't really do anything about this in a manner where there will be no zero overhead. It's important to note, because very similar issue happens with macros. With macros, it's a one definition rule violation. With contracts, it's not. It's explicitly specified to allow that. And compilers actually forbidden from doing inter-process optimization, which could lead to some issues when compilers believe that we will do this check, for example, on a pointer, and in some other function, it will omit a null pointer check. Actually, I have an example. It's not a benign ODR violation. It's actually ODR compatible, but linker is allowed to get whatever it wants. You get what you get. Who believes it's bad? Or question? Yes.
It's bad.
It's bad. Yeah, it's a hot topic, but I really I couldn't find any rationale of how to fix it. Yeah, I understand it's not good. No one says it's good. We don't believe it's great, but we can't really do better. There is no design where it's possible to do better without runtime overhead or fixed semantics. Because one of the important things to understand, for example, Windows, where you can't really mix release debug at all. And usually what we expect, release and debug, will use one single semantic. You will not mix it. It's not really a thing that will happen accidentally. Yeah, but there are some ecosystems where you actually mix release and debug bits, which is not, it's very bad. You shouldn't do it, never, but there are. And for these ecosystems, it's important we should be able to mix it in some way. And it's for introduction of contracts to old code bases where you have a lot of old binaries. You will not be able to rebuild every single thing in your ecosystem, but you want to use contracts else in addition. So we have a very good reason to have that behavior. It's not great, it's bad, but we have a reason.
Yeah, but so one of the big things I was hoping contracts will solve is when you're vendoring third-party libraries that are compiled, and usually you only get the release library, right?
Yes, it was an argument which was made, but even right now, for example, you have a release binary from Valve, for example, or something like this. Does it use macro today? Are you allowed, for example, if they use macro, you are not allowed to use debug on your own. You need to use the same macro mod for them as well. And also for your runtime library, you need to enable the same thing. Like you need to make sure everything is compatible, and it's on you. Yes, yes. If your vendor provides you only one version of the library, you are forced to use a mod which is compatible with this. And like it's very important to understand that this ODR like compatibility mod is specifically made to make situation better, because otherwise, okay, your vendor provides you a release binary. Contracts do not do ODR relaxation, and you accidentally mix them. What you get, you get to ODR revelation, like it's worse. But at least in this case, because like even to understand, this problem is very specific in very specific case when you have like inline function, which is not inlined on the call side, because if it's inlined, like everything is fine. And it's not expected to be that much big of a problem, even from the point of like theory on the contracts, like how they're supposed to be used. Because every time you violate a contract, it's based on the narrow contract by Lacus rule, it's undefined behavior. So like if you actually invoke some behavior which is problematic, you're kind of already in the undefined behavior space from like design point of view. Yeah. Another.
Sorry, but does that mean that like if I only have one version of the vendor library, I cannot enable contracts in my entire project just in case that it doesn't introduce ODR with the specific library?
No, quite the opposite. Like these contracts, as they specify right now, ODR is relaxed. So you can, like, even if your vendor provided your binary with enforced contracts or on the other, observed, doesn't matter. You can compile with your own semantics. But you will have this one little case where you are not sure which semantics you will get. But by the definition of the proposal, you can't realize that contract statement will be called. Like, it could be called 0 times, it could be like any number of times. It's like, it's the idea that in these cases, you get what you get. Like when you start to mix real life and this stuff, you have this guarantee that it's not an ODR violation, which is better, which we do today. And technically, even, for example, even today, if you like would force, there's another argument, for example, right now we need to build like 32 binaries for different configuration. And with contracts, we'll need to multiply it by 4. But actually, it's not by 4. It will be by 16, because you have additional semantics in the contract, and you have different like calling, caller convection. And actually, it's not quite this, only this, because in compilers, usually you have additional flags, so like you can multiply it as well. It's not a very good argument because it just doesn't scale to like somehow fix to this. Like our only alternative is to somehow prevent it on the ABI side. But in this way, okay, you are forced to use this configuration always. Like, what's the point? Like, you have less freedoms, like, to do what you like. Is it really like a good thing or not? I'm not sure.
No, it's good. As long as I'm able to choose how I want to run my code and get the most out of the library.
Yes.
Yeah, that's the idea here, right?
Yeah, because it's a very important idea that with contracts, it's like kind of like a best effort. Like, it's the best what we could do with C++ like today and probably in any visible future, because there is no design which fixes all these issues. Like modules, they do nothing. Like we completely wasted everything around this. And so, yeah, you get what you get. There was very interesting comment from one of the compiler implementers, actually, which proceeded up until Kona, which was in November or something around, yeah, in autumn, that contracts introduce a supply chain attack. For example, in this case, what do you believe happens if we compile with contracts enabled, enforced, like in a debug mode? Like with assertions, there's an issue with with IPO, right? That compiler sees that there is a check for this pointer, and it will throw, not throw, call a contract violation handler. And because of this, it can technically elide this check for the null pointer on the call side. But with contracts, it's not allowed. Because compilers, they are not allowed to assume how many times contract asset is invoked. Doesn't matter which semantics is called. Like compilers should always check for null pointer on the return value of this function. So yeah, there is no supply chain attack.
What's the supply chain attack in general?
Yeah, the idea, because all of this is translation unit dependent, you can specify semantic for a translation unit. You could, for example, add some specific semantic on your, like, you have a dependency. This dependency added their own semantic to this binary. And when you pull like an updated version, suddenly a function which in your own application you called like with enforced semantic, for example, it started to be called with observed semantic. And because of this, you have a vulnerability in some way, because it's no longer checked.
So like in this case, we are calling from the context of who we are calling f, and there is a check to null pointer, but if somebody converts it to observer, and b optimizes away this another check in the foo,
yes,
that will be supply chain attack.
Yeah, it was the idea why it's a supply chain attack. But in the wording and in practice, like compilers actually do it. It's not like some idea how compilers should do it. Compilers actually prevent this thing.
So they will evaluate this condition 2 times?
Yes.
Yeah, okay.
Always. Yeah, and when C++ 26 started to get near, there was a meeting in Kona in the autumn, and you could see a lot of like posts on Reddit, like some talks from Bjarne, where everyone started, okay, maybe we need to pull contracts again from the draft. Maybe like there are some issues. There have been 17 comments from 7 national bodies. Like, it's a very big thing. Maybe like not everyone is familiar with how it happens. For a standard to be released, there should be consensus among all national bodies. It doesn't matter like what the committee itself says. Like, the official standard is released only when all national bodies are voting it in. And when you have a lot of national bodies which are against the current standard, they're not voting on a specific feature. They can say, okay, we would like C++ 26, but without contracts. No, they can only vote, okay, do we want this C++ 26 or not? And it's like a big, big issue. And a lot of the process in the later stage of the standardization is to ask, okay, how can we get a consensus on the C++ 20, on this working draft? Not only feature, but like what can help improve consensus? What can help some national body to say, yes, okay, this standard is fine. Maybe we don't like it, but it's fine. And yeah, during the meetings, there were like a lot of warnings from Microsoft that doesn't matter what you do, like we will not implement it. We failed to find any supply chain attacks, like all comments, papers related to that, so everything was clarified. By the way, I say we, it's not quite correct, because I'm not a committee member, but I have access to minutes because of the one funny thing and some connections. No really new information was discovered, like everything that was specified in this huge rational document was pretty much already said. And consensus held in the end, like we couldn't actually compromise on some changes in the working draft. Like everything people talked very loudly they wanted. They couldn't gather support for this in the committee. And it was a little bit surprising to me because like there was a lot of drama. It was very nerve-wracking. And Lukas said in one of the mailing lists very nice that no one really listens to this complaint because everyone already discussed all this question. Like no one is interested to read it again and again and again for years. Like, so everyone already said. And the Atas address comments with P384.6. It has 42 pages with like a huge document because like by the process, they are required to address every single comment from every national body. Doesn't matter. 17 comments were sorted and addressed in 17 concerns because like there were quite a lot of duplication. Each explanation was followed by exhaustive links to previous discussion, existing polls, like not a single like decision which is controversial was done by some personal idea of someone. No, everything is voted. Everything voted not just in the study group, but it's not like exclusive cabal of people who like planning to somehow make some bad stuff to the standard now. And yeah, with comments, there were a lot of issues that a lot of them actually were duplications. Like a big concern that this proposal lacks experience, like build experience. Someone says that we don't know how it will affect build flux, like how it will affect binaries. Like you propose, okay, we add this build flux. We have no idea how to add build flux apparently. And user experience also defined is in a very interesting way now. So from the point of some members of the committee, user experience is when you ship the feature in the release of the compiler. You can't have like a branch which you tested on some project. No, you need to properly release it under some flag maybe. And only this, in this case, you can call it as user experience. Anything else, there is no user experience. There's too much implementation defined behavior. Also a lot of comments. Constification, for some reason, like it's a huge controversial topic. Like people believe it's not teachable at all, which I'm a little bit confused, again, because Lambda, I think, like the same thing, absolutely. Mixed mode, observe an issue. Yes, it's a necessary evil. We can't really do better. It was always an issue. There is no like even some idea of how to solve it in a decent way. Like you get what you get. Apparently, someone believes that the proposal lacks features, which is fine, but like the proposal lining up. The proposal already very big, like 120 pages. How many pages additional you want? And there was one very useful, I believe, from Finland. It talked about how contracts do not solve safety, like at all. You can grant, because you can disable them, like what guarantees do you get? And it's fine, because the proposal actually doesn't talk about this at all. There's no motivation for this. It actually apparently doesn't help static analysis at all, even so we just had a talk where folks from Microsoft managed to use information from contracts to improve their static analysis. But after this, Microsoft person came in and said this talk was in no way an endorsement of contracts because Microsoft believes it should be pulled away. So it was like a little bit strange. And of course, Microsoft ABI was mentioned, but it's a very hot topic. And some people actually said that this proposal is unimplementable because it doesn't work on Microsoft's x86, like it has real runtime overhead with and there's a funny bit during this talk because the paper was 42 pages and some of the comments were duplicated. And one very helpful person decided to help every committee member out to understand what's going on. And they decided to fit all the paper into the ChatGPT and get like a shorthand version of everything, like with different wording and stuff. And I have no idea who this person was, and the chat was lost, but yeah, it was not very professional of them. And other comments which were made, for example, you may have seen a talk from Harald, who does C++ Sweden. He was very critical about this. Like, there's so much work goes into this, and like people dismiss it. Like, but you can't really convince anyone at this point. Like, every single argument is no. Like, what can we do? Yeah, this is a very long comment, and this is an example of how, just to showcase how this proposal addresses these issues. For example, implementation defined, right? You have 31 case of such thing. Like a lot of complaints about this. So I will give you time to read it. Yeah, I believe it's like very reasonable. We viewed the issue, we addressed it, like we made some trade-offs and stuff like this. It seems to me very reasonable. It's certainly not how you would react to this, how Harald did with his comment.
I don't understand. Why they didn't decide whether they will be evaluated or call your color side?
Because it gives implementation freedom. As I understand, it allows in some cases to compile one binary with one, like you can introduce contracts to one binary, or for example, you have an old binary which you don't want to recompile, add contracts to interfaces of this binary, and it will enable contracts for this binary without recompiling it. If you have like a Collier semantics.
But only for so only for preconditions and postconditions. You cannot put.
Yes. Yeah, because contracts is a statement inside the function. You can't really change how it's. Yeah.
But this, I think at the end everybody will just put it on the Collie side.
Different implementation to different things.
Yeah,
like I was told.
3 compilers in total. Like you cannot.
No, I'm not sure why, but like I was told by implementers who do it in Clang and in Clang, yeah, that like the different trade-offs for this. I'm not sure. Like I'm not an expert in this specific thing. Like I refer to the others. Like there is reason to this relaxation in specification. Yeah, there was a funny bit during the discussion. So there is a study group called CG15, which is DAS tooling. And because a lot of the committee members, they had a lot of trouble to understand like how this proposal fits into like build experience. Do we understand how to add build flags to our compilers and stuff like this? A very helpful committee members decided to ping both open and closed mailing lists into the same mailing lists. Effectively, because SG15's mailing list is open, everyone who is not a committee member can see it. But when you start to like add people from a closed list, they don't quite notice it. And they start to write like as if it's a closed list. And at some point, one of the members decided to helpfully share some user password for the wiki. And you could, at this moment, you could read like some stuff. It was very interesting. Yeah. Yeah. I noticed it first, actually. Yeah. Another, side topics. It's not even like all of the stuff is the public mailing list. Like I don't include anything from the private ones, but I know stuff from the private. It's worse. And this one was said in the same sentence to the next. So like, how can you actually expect some feedback from these comments? I'm not sure. And yeah, discussions effectively came to some stallness. Like everyone is tired, no one has like any strength to do any arguing. Yeah. Let's do a poll. I promised you a poll, so we will do a poll. C++ contracts, are they important to you? Yeah, it's a very strong question. Like, and it's not my poll. I actually took it from one of the paper made by very, very serious people in the committee. And it had 3 options. One, who uses C++? Yeah, almost everyone. Who doesn't use C++ because it doesn't have contracts? I guess no one. Okay, who doesn't C++ and adding contracts will not change your like mind? Oh, 1 person. 2, 3, great. So like it's actually happened. Sorry. Yeah. So in one of the papers, they decided to post this poll. I have no idea why. Like what? They do make a disclaimer that like it's an informal one, it's a scientific. I guess, yeah. Okay. Yeah, but this still states, this poll suggests that contracts are not a widely desirable feature for some reason. Like, yeah, it's from the paper called Contracts Do Not Belong in the Language by very respectable people. Personally, yeah. There's a lot of confusion about contracts, again, from very, very public members of the committee. For example, what does safety mean in the relation to contracts? Do contracts solve safety? They don't really talk about safety in the proposal, but somehow like people think about them in that way. Yeah, the same. Like apparently they're strictly worse than writing an assert, but as we discussed here, like they specifically provide this ODR violation relaxation, which I think is very good. Like in cases where you need to mix like release debug build for some reason, like. They're strictly always better than asset from my point of view. Yeah, we don't know, obviously, how contracts interact with safety, and apparently with profiles. And profiles, I could make like an additional talk on what I think about them, but what not they are, because no one knows what profiles are. And since contracts do not address the issue of mixed mode builds, but the problem is contracts literally address this. They have like a whole chapter in the proposal called mixed builds, but some people believe they don't. And they apparently address it less than CSS, but in CSS case, you do ODR evaluation and nothing is supported, but contracts actually say, okay, you get what you get from the linker, but it will not be like undefined behavior. It's not ODR evaluation. And yeah, the very strange issue is that since contracts introduce new build configuration, we don't know what to do with this. We don't have experience. CG15, they helped a lot people to understand we do know how to add build flags. There's some cases of magical thinking. Like it's a little bit, I will showcase what I mean here. Like in the same discussion where people, they ask, okay, what, you don't like the current contracts. Which design, like which requirements do you need to solve on these contracts for them to pass? Labels are a tool to scope contracts to some specific use. Semantic. So for example, you make a contract statement, you don't want this contract statement to observe never. So you can force it to always enforce. But these persons, they don't want to decorate every single pre- and post-contract access statement with these labels. They want to automatically, for compiler, to somehow figure out this contract statement will be in this semantic or in another semantic, stuff like this. Yeah, and we don't really want to turn off contracts with build flags. For example, we could use like some model-based maybe case where we could pass a flag to a model when we build, and it would turn this semantic for the whole model with IBI some guarantee maybe, but they don't want it. They don't want from the build flags, but also they don't want to configure it from every single statement. So it's like, how I don't understand it. But we still do want to control semantics. And at this point, I'm a little bit lost. And it's all the same like mailing list chain. It's not like separate statement from different people. It's the same person, very respectable. They see like design they want to see, but I'm not sure anyone can see it. And yeah, and of course, because models can help us anywhere, we want like in normal headers as well. So it doesn't matter use translation units or not, compilers somehow need to figure out these symbols are in the same component. Yeah, so feature must not decorate every statement. It should be component scoped. We have no idea what a component is. It should not be controlled by build flags or any kind of sources. For example, you could theoretically wrap the statements in a macro. We don't want to do it. This feature, but still it should be configurable explicitly by the author of the code. So if like I make a library, I want to guarantee this like enforce semantic always happen. I don't know why. And the feature must correctly detect which definition belongs to which component, but not based on models. So like you have just some percent. And it's like, it's very interesting when you, yeah, what do you think? Like, can we satisfy it in some way? Maybe there's some implementation we don't know yet, probably not. Yeah. Yeah, it's, I just wanted to include this old Twitter post, the attention to the date, I guess. Yeah. Yeah, it's the same kind of thing, like profiles, models, everything. Like we already we're a few months away from some greatness. And another issue, like because we failed to convince anyone like about our position, what do? We want to say like, okay, maybe not now, like C++26, we are not ready. Maybe if you wait another 3 years, maybe later, because like you can always argue later more. So you have a statement like, unless we like solve all the issues, like we strongly recommend from adding them to the C++26. We want a white paper. It's like separate document, which is not official, where we can gather some experience. The same, like given circumstances, white paper. And it's funny because one of the papers explicitly do this quote. So like they admit that it doesn't matter what we say. There is no argumentation left anymore. Like everyone has made their mind. And people, there's two groups of people just referring to their own papers, like, and that's it. And they're like huge chains of reference. Like one group has 17 papers in their reference, another 24, and it's the same groups. Like, so what am I reading? And all these papers are repeating the same things. Like you can read one paper and believe you read like 20 of them. And and the issues during the contracts discussion, multiple implementers, like notably Clang and GCC, they asserted that they are no longer interested in deploying features that are not in the published standard as a policy, like how they did with concepts. In Clang, for example, they have an implementation. They express the issue that right now, after concepts were changed in some way, they still need to support this implementation because people are apparently reliant on this feature, and they no longer want it. Like the same with coroutines, like old coroutines, the same issue. Models are more useful because like in Apple, they do use them widely in other languages apparently. But they told that, no, if it's not in the standard, we are not going to implement it. But as we remember, by definition of some committee members, if the feature is not released in a compiler, it has no user experience. And if the feature doesn't have user experience, they don't want it released in the standard. But this condition it's not quite applied consistently, I would say, because there are some features which didn't have field experience and no one bothered with them. Some features are not even implemented in theory, And there's a note from Bjarne. He doesn't like the feature at all, but as I understand, it's mostly because it takes design space. So contracts, like the name, very nice. Maybe we would want to do some different behaviors with contracts. And there's additional syntax because it's still, it's a very heavy choice. We do this additional specifiers. It eats on the design space of the language. In the future, it will be pretty much impossible to change it if we find some crucial issue. And I want to talk about another bit which I find not very nice. There's a lot of insistence from critics, just different committee members, not even just this person or like different people, that they don't really, they want some implementers to find some theoretical implementation of an alternative which solves the issues. So like they don't want to prove themselves that there is some alternative like solution. They want like implementers of the feature to implement it themselves, to find solution. It doesn't make sense. And there's a fun bit maybe. Who never heard of the Russell's teapot? It's a famous analogy to how we can't really prove unsatisfiable, unfalsifiable claims. So we could say that there is a teapot on the Earth's orbit somewhere in space, and no one can really prove that it's not there. It's like so very small, like not a single device can detect it. And to prove that it doesn't exist, like we need to check every single space in space. So it's impossible. And it's the same thing here. Like if you claim that, okay, maybe there's some different implementation which solves every of our complaints, you can't ask for it from implementers because it doesn't work like this. They can't prove that such implementation doesn't exist. You can always claim that, like, okay, they tried to implement something and did it work. Maybe they did it badly. Maybe they didn't try hard enough. Like, how does it work? I don't understand. And what's next? What was made to come back in UK? Because it was consensus to keep the contracts, but it was decided that to alleviate some concerns, we will introduce additional syntax. We don't know which syntax it will be. But it will be non-ignorable. So we will never be able to do observe or ignore it. It will always be enforced. And it's sort of like a better alternative, but it's very important to note that it's just an intent to try to come up with some feature because it believed to improve consensus if we do. but it doesn't mean there will be such feature. And it's actually very unlikely it will be, because people, like, one of the main concerns that we want this syntax to be default, and the one which can be non-enforceable to not be default. But it was voted against. So, yeah. And of course, it's very important to note that C++26 is not yet released, and contracts can still be removed out of the draft. And one of the very interesting developments of this drama story, there was a paper where implementers started to complain that people believe they're adversarial to the design, like, but in very abstract terms, such as, like, the committee doesn't respect how to implement features, but there's the fun bit that it's not about models at all. Like, models from the point of implementers are perfect. Like, everything is great, like, they implemented greatly, standardization, because it's shown for the past year there's not a single different change, but they're very strong concern about contracts, because contracts, they do not listen to implementers, to one implementer, I guess. Yeah, and that's it. Thank you a lot for listening to my rant. If you have questions, I can answer stuff. Do you believe contracts are useful? Like, yeah. Because, like, are they useful in this small form? Like, who uses macro sessions in their code base? Like, better question, yeah. Always. Just. Do you have a custom macro for a session? Like with custom behavior. For example, in one of our projects, we have macro which does exception throwing in release, like, because we can't disable them in some cases.
We have custom macro, and I think it's disabled in all builds.
In all builds. In all builds. Okay.
Yes.
Okay, I guess. Yeah. Okay. Then thank you a lot to listen to me.
Thanks, everyone. Thank you, Aleksandr. There's beer in the fridge and soda.